Good evening, everybody. Thank you for coming to watch me again. We're back with another analysis video for Tropical Cyclone Dikeledi. A lot has changed since the last video that I made. We're going to be going back over it today as it makes its way to the end of the Mozambique Channel, and we'll be leaving it soon while it continues its rapid intensification process which had begun not long ago. Let's get straight into it. So, here is a current satellite image of the cyclone of the system. I should probably be looking at a floater to begin with. I like how Cyclonic Weather has a restructured page now with a better accessibility. Generally, everything looks a lot nicer now, so that's really good. But besides that, let's take a look at the latest satellite loop from the geostationary satellite Meteosat 9 that we have here. So, here's a loop. A lot different from what it was when I last recorded an analysis video on Dikeledi. And we can see here it's got full-on vertical hot towers wrapping, evident organization, developing eye, the eyes quite evidently warming. Quite a lot of banding here as well. Let's go over some of these features. So we've got a nice developing eye there. We can see here, though gone for now as a vertical hot tower develops and attempts to wrap. Many vertical hot towers are now wrapping, attempting to solidify the central dense overcast overall that seems to be developing quite nicely as well. So it's not quite stable, but it is quickly intensifying. Quickly trying to develop that nice, mature structure with a warm eye. And we'll be able to see this nice progression on microwave imagery as well. Here's the latest image that we have from 1613 Z or Zulu time with the latest SSMIS F16 overpass here. On microwave, this is the kind of under the hood structure that we have. A nice, evident developing core. A bit weak on the east side there, but obviously we see that nice vertical hot tower evident on the image there, and another one there. We probably have a lot more of a solidified core right now at this time, because if we do look at this loop and we do look at the time, we definitely do see a bit more of a solid, probably structure on the east side there, quite clearly, with a new vertical hot tower around the west side. So overall the core is probably solidifying underneath as well. It's doing quite well. We also notice, as I said, we have quite a bit of a bandy structure here, quite a lot of bands in the around the periphery. Quite noticeable here as well, particularly on the west side there, and some banding developing on the east side. Aligns with the infrared view that we have here. What that does suggest is that obviously while this tropical cyclone is intensifying quickly and is obviously getting its stuff together, is really heading forth now. In the coming future, really, if conditions do not prohibit, and the conditions will, I guess, it doesn't end up getting sheared to death and vertical wind shear doesn't increase, which it is expected to happen soon, but if this banding structure is maintained, a short-lived attempt at an eyeball replacement cycle is certainly possible in not too long, if that banding does become more prevalent. But we'll have to see if other environmental conditions end up suiting an eyeball replacement cycle, because it could be a case of vertical wind shear increases very soon, and that disrupts any attempt of solidifying secondary eyeball formation, which means an eyeball replacement cycle doesn't happen. It will weaken either way. There will be a terminal weakening point happening very soon. We're looking at about maybe 18 hours or so this cyclone's got left, maybe less even at the time that this video gets published. Because let's look at the environment here that we have. This is 0Z, this is now closer to the time of recording. We can see broad, oh that's the wrong thing, broad, very nice upper level anticyclone layers embedded within. So it's definitely benefiting off that, and benefits of that poleward divergence it has there. But we must also understand that this is going to, as it tries to go after that deep layer trough, it will be interacting and embedding itself within the westerlies, evident here, and it becomes more embedded within that westerly flow, and therefore that deep layer shear will be increasing. We can take a look at this deep layer shear increasing with a better view on soundings. This is 24 hours out from the initialization, so this is 18 hours like I said. Evident shear increases here as each sounding goes forward. Evident max shear and deep layer shear increases there. Both totals are increasing there very clearly. And if we look at the profile here, while the vector suits the movement vector of the cyclone, obviously the winds are just overall along the deep layer. All layers are having very strong winds, and they will not suit any development of the tropical cyclone as it moves into the subtropical latitudes. And we can also have a good view here on the plot here. That relative humidity structure really does become displaced, disheveled, and overall the mid-level circulation decouples from the low-level circulation, meaning that it loses its tropical characteristics and most likely engages with an extratropical transition. Also evident here by looking at the kind of frontal boundary that's on the surface wind plot there. You can see that kind of wind shift that is quite evident there. And we're looking at this maybe 72 hours, 96. This will be kind of when extratropical transition becomes evident. And even if extratropical transition doesn't end up happening, it will be a case of degenerating into a post-tropical cyclone because it loses its tropical characteristics. It no longer will have a mid-level circulation that is sufficient. Convection will not be around. We'll have dry air intruding into the circulation, dominating the environment. And that is what I mean by losing tropical characteristics. It will no longer hold the criteria, it will not hold what it needs to suit the criteria of a standard tropical cyclone. Here's a better view of the environment. We have a very nice broad upper level anticyclone like I mentioned. This is a real-time atmospheric motion vector plot that we have for 15Z, so this is 3 hours ago from the time of recording. And as we can see, their main focus, because of it interacting with the deep layer trough, is the significant poleward divergence here as it taps, as the outflow really strongly taps into the 200 millibar jet. But because it's embedded with an upper level anticyclone, we've got some flow here coming as well. So it's overall very nice upper divergent flow that the cyclone is benefiting on, and one of the reasons why it's intensifying so quickly now. Another reason is, let's take a look at the sea surface temperatures here. Very nice, warm. I discussed this. We're looking at 30 degrees now. But it will be decreasing, well they are decreasing now really, assuming a current position of the cyclone, maybe somewhere around the latitude of the southern tip of Madagascar. Let me get a better colour for a better view here. Around there, assuming a current position, yes I would be right, we're going to see already decreasing sea surface temperatures. That's not to say that they are no longer sufficient, it's just that the 30 degrees good oceanic potential was a bit better when it was there. This was the 12Z position, that's 6 hours ago. Now, sitting at around 28, we're still not doing too bad, but the temperatures should be noted, they are decreasing, and they will decrease over the next 12-18 hours or so as the cyclone moves that way and moves closer to the fringe between the warmer and the cooler waters, aka the 26 degree isotherm. I want to take a look more specifically into the soundings of the current environment here, of what we have now. So this is 18Z, this is what we have now. The overall deep player shear, 5 knots, very conducive, and the overall max shear in the mid levels is 14 knots. Let's actually take a look at this profile specifically in more depth. Overall, the vector of the kind of shear that we have here is aligned, doing pretty well. It's not actually doing too bad in relation to the current steering and the motion of the Cyclone itself. So overall, any kind of shear effects are lessened in a way because of the steering flow and the way that the Cyclone is moving. So overall, quite conducive. We can see nice relative humidity mass is holding on very nicely, so any moisture is expected to be held very well. And that overall proves that we do have quite a favourable environment. I've already discussed the upper level divergent flow that we have here. Now let's talk about steering, because I usually talk about steering at the beginning, but completely fine, we can continue to go with that now. So in terms of the trough and the ridge pattern, this is the current position of the Cyclone. And we can see this nice, I keep drawing the sounding box. Overall we see deep layer trough, very evident there, will be moving that way. I can't draw arrows ever, can I? We got these nice deep layer trough moving that way, moving eastwards. That will continue to bring Dikeledi southeastwards, turning more eastwards, turning more southeastwards in not too long, as it tries to engage with this incoming deep layer trough that I've just talked about, and will eventually merge and attempt to undergo extratropical transition. All the models are generally in good agreement with this. At this stage, the way that the interaction with the trough happens may cause some slight disparity within the guidance, but the overall idea of now heading southeastwards, accelerating southeastwards, trying to catch up with that trough, that idea is solidified. We don't expect any other solution really. It would be better to take a look at the ensemble models that we have here. Essentially, yes, we've got that nice, very obvious trough pattern moving this way. I don't think I need to go into this much further. Very simple, evident pattern that is likely to evolve over the next few days. The differences between the models I think would be worth discussing. Let's see if there are any, because I haven't actually taken a look at this in so much detail like I have now. So we got obviously the GFS at hour 24 with the 12Z initialization. Let's compare this to the EPS. The trough progression in the short term seems to be fairly agreed upon. We're looking at 48 now. Let's take a look at the GFS. Overall, same pattern. No, not really that much change. And later down the line, we're also seeing that the general pattern is expected to be relatively similar. So I think if we take a look at the various ensemble track model plots, we should have a good confidence. Sorry. We should have generally good confidence, not only between all the ensemble members within the individual models, but I think between the models themselves as well. Between the two major ensemble models, we should be having good agreement on the general track. Now, speaking of track and the track pattern, the kind of track evolution that we've discussed and are expecting that way. Let's take a look at the official Météo France forecast that has been released not too long ago. So we're currently in the intensification phase, like we've discussed, and in their cone it explicitly suggests that we are looking at a short, intense tropical cyclone peak. I discussed the possibility of this on my previous two videos that I made for Dikeledi, and it looks to be playing out well now in this kind of form. Short-lived intense tropical cyclone peak before slowly weakening under the influence of increased shear, interacting with the westerlies, but also benefiting from baroclinic influences as it interacts with that deep layer trough. And hence, we do have a transition into a post-tropical depression, and then later on we do have a weak low pressure area forecast as the low ends up decaying, loses its tropical characteristics, and ends up becoming a remnant low. Now, what I do want to know is that yes, we do see intense tropical cyclone forecast. The lower boundary for that on the Materia France scale is 90 knots in 10-minute winds, which would be a mid-range category 2 if taken that at face value. That converts to, I believe it's either 100 or 105 knots for the 1 minute standard. Now, what Materia France forecasts, and I don't think their forecast advisory is out yet, but their initial advisory that is issued here, their standard advisory that is issued first, estimates the current intensity at 75 knots in their winds, so that's 85 knots 1 minute. I'll go into why I disagree with this slightly in a minute, but first I want to go into their forecast, which is 100 knots, 10-minute winds for Materia France. That's in 12 hours, that's forecast, with 90 knots also forecast in 6 hours. So that would be a 15 knots increase in 6 hours if this ended up verifying. But yeah, the 100 knots, 10-minute winds that are forecast for 12 hours from now would convert to 115 knots 1 minute, which we're looking at a very solid Category 4 equivalent hurricane at this time, if it was to verify. And there's good potential for this, especially with the very nice environment that Dikeledi is trying to utilize, and the fact that this intensification rate doesn't look to be stopping. Speaking of kind of how we interpret intensification rate and the kind of development that we have on infrared imagery. Now obviously we're seeing this nice structure that's kind of playing out here. A 75 knots estimate is, in my opinion, a little low. As I said, I would discuss why I disagree with the estimate that Materia France gave. Look at the structure here. We kind of do have a very unstable convective structure here, and that's not surprising. But overall, we can still analyse that there is a nice central dense overcast, and intermittently we do have quite a nice eye around. At peak, it reached off-white colour, which is over this. It's minus 30 to 9, positive 9 in degrees Celsius. And we see here, warmer eye typically suggests a stronger, more intense tropical cyclone. And as that central dense overcast tries to develop and vortical hot towers wrap, we do see that eye warm. But obviously, because of the unstable structure and constant vortical hot towers trying to wrap, still as an evolving cyclone, those eye temperatures will fluctuate. But at this development, we can kind of analyze, and we'll have to use average Dvorak T numbers, data T numbers, for a bit of an accurate analysis of the actual final Dvorak T number and trying to get a grasp of what the actual intensity is. This kind of looks like we're probably looking at a 5.0 here at a rough guess. This frame, I think, if we're looking at this, first of all, I should note that this should be kind of a basic kind of look at what the kind of intensity is based on infrared. This is actually higher resolution imagery than what I should be looking at. I think if I'm not wrong, the Meteosat 9 infrared imagery, I think it's 2 kilometers resolution. I think the recommended Dvorak technique resolution for infrared imagery that should be observed, I think is 4 kilometers, which means that my analysis here based on this imagery may be less accurate to the Dvorak technique than it should be. But it gives us a good kind of baseline kind of idea on what the intensity could be regardless of the wrong protocol that I'm utilizing. Going by this and going by the Dvorak technique, looking at this type of imagery, I think this may barely just fit a 5.5 classification, which would be equivalent to 102 knots. But we cannot take these singular frames at face value. As I said, in this kind of situation with an unstable structure, it would be much better to take 3-hour average DTs, which, as I said, looks to be maybe 4.5, 5.0, utilizing a mix of eye pattern and embedded center pan when central dense overcast becomes the dominant feature. Which would probably suggest a kind of intensity range from 75 knots to 90 knots. I would probably go, with how these intensifying systems usually go, 85 knots would sound good. Maybe for 1 minute kind of standard, really. Maybe 90 knots if I was generous. Now that could also work, really. That's on the upper end, and intensifying systems can be stronger than they look at times. So that could be suitable. Which, in second thought, now that I'm obviously thinking about this a little bit more, it's not that much different from the Météo France estimate. 75 knots on their latest advisory, that's in 10-minute winds, so in 1 minute standards that would be 85. Which, as I said, I noted that as a possibility. I always like to consider my estimates in 1 minute following the American standard, that's just what I'm most used to. And to go on to more onto analysing the current estimate, we've got to take into account all the available estimates that are around. So I'm going to reload this page just to see if any estimates have updated. It looks like we may do have new synthetic aperture radar estimates that have just come in, because I do not remember seeing them on the plot before, especially this one. We also have a new Dvorak fix that has been come in. I will have to see who that might be by. That is from yeah, that's from Météo France. I'm looking at this is from Météo France. Yeah, you can see the logo at the back, which suggests it is from Météo France. I don't look at this. I look at the code that they have there, and obviously I can see it there as well, just to identify what agency they're from. And yeah, I mean, you can see they've got a 5.0 analysis, which I think does, it's around 75-80 knots that it converts to, in terms of their winds when they estimate it. So that's good. At least there's good agreement between kind of my thoughts and the official agency's thoughts. In regards to the current intensity. But what I did want to go to is kind of seeing how the objective and any other estimates really kind of grasp the idea of estimating the intensity of this cyclone, as I did. So obviously the Dvorak analysis suits my kind of thinking. We did get a 5.0, which is good. I agree with that, and that does equal to 90 knots in the 1 minute equivalent. We also had synthetic aperture radar data, which also is close to the upper bound. Data from SCR it can vary. There's a lot of inconsistency with its values and its outputs on various storms, and it's difficult to use it to estimate. But if it aligns with most of the data, and if it doesn't seem too erroneous, you can consider it into estimating a tropical cyclone. But you have to do it right. You must have experience, and it must obviously be taken consideration very lightly. You must take a look into it quite deeply, see if it's okay for use. And I mean, I haven't taken a look at the past, but judging by the fact it's close to the upper end, and how current structures go at this current intensification rate at this time, it might not be too bad of a retrieval, really. So that could suggest an idea of a stronger cyclone, but it's best to be a little bit more closer to the middle. There is a bit of disparity between a lot of the guidance, a lot of the estimates that are down there. It proves that there's quite a big disparity, quite a big range. That typically happens with unstable cyclones. But overall, still, while they might be on the weaker side, and we do believe that it might be a little stronger, we'll probably see this structure and the kind of evolution here. We already see a big fat vortical hot tower here on the east side, and a new one wrapping around there, getting a bit larger. This could be the beginning of an evolving, larger, more stable eye that could warm a bit more than it did last time on its last attempt here, and we could see some real aesthetically pleasing evolution here as the cyclone heads southeast and actually organises further. It doesn't have long, and it will be passing south of Madagascar and soon be weakening, but currently it seems to be doing fairly well to try and sustain itself, develop at the time that has left. I agree with Matteo France, maybe not on the kind of intensity prospects and the forecast that they have, because I feel like it may be a little too high with the amount of time left. Sometimes these cyclones can surprise us. It's not easy to, even nowadays with the amount of stuff that we have, the amount of advancements we have, it's not completely easy. It's not totally easy to be estimating it's not easy to be forecasting as well how much intensification could be happening with some of these cyclones in some of these rapid intensification phases. One thing I can say though is this looks to be on its way to major equivalent status, and it could probably be heading to a category 3 equivalent strength, which would put it as a pretty significant tropical cyclone. Would it reach category 4? It's unlikely in my view. There's a good possibility. It doesn't have time, as I said, but if it does speed up its organisation, it does seem to be getting itself together a lot, it could get to category 4. One thing for certain though, we're probably nearing major status now. We're definitely getting a strong tropical cyclone out of this within the next few hours. This may be outdated because of how quickly this intensifying cyclone is going, and my videos do take some time to get published. But yeah, that is my analysis for the time of recording. I hope you guys have found this informative. I hope you guys enjoyed this video and have found out a little bit more. We aren't expecting any land impacts apart from maybe southern Madagascar there. Brief gale force winds maybe on the periphery. But apart from that, nothing too significant. We're getting a nice tropical cyclone heading out to sea for the most part. Short-lived, strong peak. So it'll be nice to see how it evolves. Thank you all for watching. I appreciate you coming to watch, whoever does come. Take a look at my discussions. And I hope you guys come to watch my future videos that I will have published in the near future. So thank you for watching. And yeah, that's me, thank you. That's it from me. Take care, everyone.